So let's get started with De Moivre's theorem, LAQs. So there is one formula, that is cos theta plus I sin theta whole power n, can be written as cos n theta plus I sin n theta. This is De Moivre's theorem. Based on this one theorem, we are going to solve all the problems. And there is one extension for this, that is cos theta minus I sin theta whole power n is equal to cos n theta minus I sin n theta. Okay. Now let's take the first LAQ, that is, if n is an integer, then show that 1 plus I whole power 2n plus 1 minus I whole power 2n is equal to 2 power n plus 1 cos n pi by 2. Now you see, first we will take the LHS. The first bracket of the LHS is 1 plus I. So let's start by taking 1 plus I. Now we need to convert this in modulus amplitude form. So the first thing we have to do is multiplying and dividing by root a square plus b square. So in this complex number, a is 1, b is 1. So that is root over 1 plus 1, which is equal to root 2. So here we need to multiply and divide by root 2. So root 2 is outside and inside we take 1 by root 2 plus I into 1 by root 2. Now that is root 2 into, now the first term should be written in the form of cos and the second number should be written in the form of sine. So how, when is cos theta 1 by root 2? We know that cos 45 is 1 by root 2. And cos 45 in radian form, we can write it as cos pi by 4. Plus I into sine 45 is also 1 by root 2. You should know some basic values here like sine 0, cos 0, sine 90, cos 90, sine 30, cos 30, sine 45, cos 45, sine 60, cos 60. So all these 0 to 90 values you should know. Then it will be easier to solve these problems. Now 1 into sine 45. Sine 45 is I into sine pi by 4. This is the value of 1 plus I. Now in the question it is given 1 plus I whole power 2n. So we will raise to the power 2n. So both the sides we need to raise. So root 2 I can write 2 power 1 by 2 whole power 2n into cos pi by 4 plus I sin pi by 4 whole power 2n. Now here 2 and 2 get cancelled, you get 2 power n, and over here we are applying De Moivre's theorem. So how to apply De Moivre's theorem? Cos pi by 4 plus I sin pi by 4 power 2 by n can be written as cos 2n pi by 4 plus I sin 2n pi by 4. 2 ones are 2 twos are 2 ones are 2 twos are. So that is 2 power n into cos n pi by 2 plus I sin n pi by 2. This is the first part of the LHS, that is 1 plus I whole power 2n. Now you can see, we'll mark this as equation number 1. The same way we'll take 1 minus I. Again multiplying and dividing by root 2 only. So 1 by root 2 minus I into 1 by root 2. Now this first number 1 by root 2 we can write it as cos pi by 4. minus I into this second 1 by root 2, we can write it as sine pi by 4. So this is 1 minus I. Okay, we are raising it to the power 2n now. So root 2 can be written as 2 power 1 by 2 whole power 2n into cos pi by 4 minus I sin pi by 4 whole power 2n. Now 2 get cancelled. You will get 2 power n into, if I apply De Moivre's theorem here, we get cos 2n pi by 4 minus I sin 2n pi by 4. 2 ones are 2 twos are 2 ones are 2 twos are. So that is 2 power n into cos n pi by 2 minus I sin n pi by 2. So this is 1 minus I whole power 2n. This is equation number 2. Now when you look at the question in LHS, you have plus in between. So we have to add these two equations. So we are doing 1 plus 2. So if you add these two equations, you will get 1 plus I whole power 2n plus 1 minus I whole power 2n. So in both the equations, you can see outside the bracket you have 2 power n. So we can take 2 power n common. So we are left over with cos n pi by 2 plus I sin n pi by 2 plus cos n pi by 2 minus I sin n pi by 2. So here positive negative will get cancelled. So you will get 2 power n into cos n pi by 2 plus cos n pi by 2 is 2 cos n pi by 2. So that is 2 power n plus 1 cos n pi by 2. This is RHS. Therefore, LHS is equal to RHS. This is LHS, right? Now we'll take the next question. So the second question is, if n is a positive integer, show that 1 plus I whole power n plus 1 minus I whole power n is equal to 2 power n plus 2 by 2 cos n pi by 4. Now here also we proceed the same way. The only difference between last question and this question is, in first question it was raised to power 2n. Here it is raised to power n. Okay, so we proceed the same way. First we take 1 plus I, we multiply and divide by root 2 plus I into 1 by root 2. Okay, so that is root 2 into 1 by root 2 is cos 45, and this 1 by root 2 I can write sin 45. In De Moivre's theorem, always make sure first term should be cos, second term should be sin. Like cos should be the real part and sin should be the imaginary part. Now this is 1 plus I. We are raising it to the power n. So root 2 can be written as 2 power 1 by 2 whole power n into cos pi by 4 plus I sin pi by 4 raised to the power n. So that is 2 power n by 2 into cos n pi by 4 plus I sin n pi by 4. This is the value of 1 plus I whole power n. Let's take this as equation number 1. Now the same way we will take 1 minus I. So over here also we have to multiply and divide by 1 by root, like multiply and divide by root 2. So this becomes 1 by root 2 plus I into 1 by root 2. So that is root 2 into cos 45 plus I sin 45. Now raising it to the power n. So root 2 we can write it as 2 power 1 by 2 whole power n into cos pi by 4 plus I sin pi by 4 whole power n. So that is 2 power n by 2 into cos n pi by 4 plus I sin n pi by 4. This is 1 minus I whole power n. It's equation number 2. Now in the question, LHS of the question, you can see you have plus in between. So we need to add both the equations, 1 plus 2. Now we need to add 1 and 2. So 1 plus I whole power n plus 1 minus I whole power n equals to 2 power n by 2 is common in both the equations, and we are left over with cos n pi by 2 n pi by 4 plus I sin n pi by 4 plus cos n pi by 4 minus I sin n pi by 4. Positive negative get cancelled. 2 power n by 2 into cos n pi by 4 plus cos n pi by 4 is 2 cos n pi by 4. Now if we multiply these 2 power n by 2 into 2, powers will be added. So n by 2 plus 1 cos n pi by 4. Now in the power, denominators are not same. So we take LCM. So n plus 2 by 2 cos n pi by 4. This is RHS and this was LHS. So therefore LHS is equal to RHS. Take the next LAQ, that is third one. If alpha comma beta are the roots of the equation x square minus 2x plus 4 is equal to 0, then for any n belongs to n, show that alpha power n plus beta power n equals 2 power n plus 1 cos n pi by 3. Now, in the last two problems, directly two brackets were given, like two complex numbers were given, and those were raised to the power n and 2n. So we were able to do it. But now you can see it's not clearly mentioned. So it's given that alpha and beta are the roots of one particular equation is given to us. So first let us write the given equation. Given equation is x square minus 2x plus 4 is equal to 0. Now we find roots for this equation. So we have a formula to find the roots from quadratic expressions. What is that? Minus b plus or minus root over b square minus 4ac by 2a. This is the way to find out roots of any equation. So from the given equation, we get ABC values. So a is 1, b is minus 2, and c is 4. Now substitute it here. Minus of minus 2 is 2. Plus or minus root over minus 2 whole square is 4. Minus 4 into 1 into 4 by 2a, 2 into 1. So that is 2 plus or minus root over 4 minus 16 by 2. 4 into 1 into 4 is 16, right? So that is equal to 2 plus or minus root over minus 12 by 2. That is 2 plus or minus root over minus 12. I can write it as 4 into 3. Now root 4 is 2. So if you want to remove minus from the root, we take I. I into 2 root 3 by 2. Now we can cancel 2 from every term. So 2, 2 and 2 cancel. So you are left over with 1 plus or minus I root 3. So one root will be 1 plus I root 3 and the other root will be 1 minus I root 3. So that is how you got alpha and beta values. Now after getting alpha and beta value, we will take them and solve. So alpha is 1 plus I root 3, right? So we take 1 plus I root 3 and try to convert this into modulus amplitude form. So in the last two problems, you had 1 plus I only. So we multiplied and divided with root 2. But here you have a different complex number. So let us multiply and divide by root a square plus b square. So what is root a square? A is 1. So 1 square will be 1. B is root 3. Root 3 square will be 3. 1 plus 3 is 4. So root 4 is 2. So we have to multiply and divide by 2. So 2 I am writing outside the bracket. 1 by 2 I am taking inside. and here root 3 by 2. So the first term 1 by 2, how can I express in terms of cos? So we know that cos 60 is 1 by 2 and sin 60 is root 3 by 2. But 60 can be written as pi by 3 in radian form. Okay, so first term I can write it as cos pi by 3 plus I into sin pi by 3. Okay, so this is 1 plus I root 3. But in the question it is given alpha power n, alpha power n. So we are raising it to the power n. So 1 plus I root 3 whole power n. This is alpha power n. So you have to raise the RHS also to the power n. So 2 power n into cos pi by 3 plus I sin pi by 3 whole power n. Now we apply De Moivre's theorem here. So it will become cos n pi by 3 plus I sin n pi by 3. This is alpha power n. Take this as equation number 1. Now the same way we take 1 minus I root 3. So this is beta. Beta we take it as 1 minus I root 3. Again multiplying and dividing by 2. So we get 1 by 2 minus I into root 3 by 2. So again, we are expressing them as cos and sine. So this is cos pi by 3 minus I sin pi by 3. This is the value of beta. Now we raise it to the power n. So it will be 2 power n into cos pi by 3 minus I sin pi by 3 to the power n. So that is 2 power n into cos n pi by 3 minus I sin n pi by 3. This is beta power n. But the question is alpha power n plus beta power n. So we need to add them. So let's take this as equation number 2 and we will add 1 and 2 now. So over here you can write in brackets multiplying and dividing by 2. Okay. So 1 plus 2 will give you alpha power n plus beta power n. That is 2 power n is common in both. So we are taking 2 power n common. So that is cos n pi by 3 plus I sin n pi by 3 plus cos n pi by 3 minus I sin n pi by 3. So these two get cancelled. 2 power n into 2 cos n pi by 3. Because cos n pi by 3 plus cos n pi by 3 will become 2 cos n pi by 3. So now powers can be added when bases are same. So 2 power n plus 1 cos n pi by 3. That is RHS. And this is LHS which we have taken. Therefore, LHS equals to RHS. Now take the next question, question number 4. If n is an integer, then show that 1 plus cos theta plus I sin theta whole power n plus 1 plus cos theta minus I sin theta whole power n is equal to 2 power n plus 1 cos power n theta by 2 into cos n theta by 2. Okay. So now here to start this problem, in the last 3 questions you had a complex number in terms of some numbers, some integers. But now here you have trigonometric values, like you have cos theta and sin theta. So before starting the problem, we should know how can we write 1 plus cos theta, because left hand side is in terms of theta and right hand side is in terms of theta by 2, which means we need to convert theta into theta by 2. So we have a formula 1 plus cos theta is 2 cos square theta by 2, and sin theta can be written as 2 sin theta by 2 cos theta by 2. So these are the two formulae which we are going to use here. So first we will take the first bracket, that is 1 plus cos theta plus I sin theta. That is, now in the place of 1 plus cos theta, I will write 2 cos square theta by 2. And in the place of sin theta, I will write 2 sin theta by 2 cos theta by 2. Now if I take 2 cos theta by 2 common, we are left over with 1 cos theta by 2 in the first term, and in the second term we are left over with I sin theta by 2. Now this is 1 plus cos theta plus I sin theta. Now if you want to raise it to the power n, because in the question you have whole power n, so we are raising it to the power n. So each and every term will be raised to the power n. So 2 will become 2 power n, cos theta by 2 will become cos power n theta by 2, and this bracket cos theta by 2 plus I sin theta by 2 will become whole power n. Okay, now we apply De Moivre's theorem. So 2 power n cos power n theta by 2 we write as it is, and here cos n theta by 2 plus I sin n theta by 2 we got. Take this as equation number 1. This is 1 plus cos theta plus I sin theta whole power n value. Now the same way we have to proceed with the second bracket also. So 1 plus cos theta minus I sin theta. So 1 plus cos theta we can write it as 2 cos square theta by 2 minus I into sin theta we can write it as 2 sin theta by 2 cos theta by 2. So if I take 2 cos theta by 2 common, we are left over with cos theta by 2 minus I sin theta by 2. So now raising it to the power, here same as it is you have to write. Now raising it to the power n. So that is 2 power n cos power n theta by 2 into cos theta by 2 minus I sin theta by 2 whole power n. Now mark this as equation number, no, we have to apply De Moivre's theorem now. So here you apply De Moivre's theorem. So 2 power n cos power n theta by 2 is as it is. Then here we write cos n theta by 2 minus I sin n theta by 2. This is equation number 2. Now we add 1 and 2. So if you add, you get LHS will be 1 plus cos theta plus I sin theta whole power n plus 1 plus cos theta minus I sin theta whole power n. Now in both the equations, 2 power n cos power n theta by 2 is common. So we add cos n theta by 2 plus I sin n theta by 2 plus cos n theta by 2 minus I sin n theta by 2. I sin n theta by 2 minus I sin n theta by 2 cancel. 2 power n cos power n theta by 2 into 2 cos n theta by 2. Now 2 power n into 2 makes 2 power n plus 1 cos power n theta by 2 cos n theta by 2. This is RHS. Therefore, LHS is equal to RHS. I hope you understand this.